the military calls overmatch. But this goal will take a long time to achieve, assuming adequate resources are available. In the near term, the Pentagon needs to halt the decline and fill critical capability shortfalls. The only way to address the eroding balance of military capabilities is to build on the current force posture, improve existing systems, leverage ongoing programs and exploit hot production lines. One of the most critical capability gaps is firepower. Russia deploys an array of artillery and battlefield rocket systems that outrange the US, while many prospective adversaries are investing in improved targeting capabilities and precision munitions. They still rely heavily on massed firepower to achieve the desired level of lethality. North Korea is reported to have deployed some 12,000 artillery tubes and nearly 3,000 multiple launch rocket systems within range of Seoul, South Korea's capital. One way to provide a major increase in US forces' near-term effectiveness is by improving artillery rounds. The Army, Marine Corps and Navy currently possess thousands of 155mm 5-inch guns. Typically, these guns fire unguided projectiles of a distance between 8 and 15 miles. By simply increasing the range and accuracy of projectiles the existing inventory of guns can fire, the U.S. military can begin to close a critical capability gap. The use of guided artillery projectiles reduces the number of rounds that must be fired to destroy a target. This will alleviate some of the burden off of the military's logistical system. The Pentagon has been pursuing improved munitions for its various artillery systems for some time with mixed results. The most successful extended-range guided artillery shell is the Army Marine Corps Excalibur. In use since 2007, the Excalibur is a GPS-guided projectile that employs a set of pop-out control surfaces to increase its range to between 24 and 30 miles. Because of its extreme accuracy with a miss distance of less than 7 feet, Excalibur provides highly lethal firepower with low collateral damage. U.S. artillery units have fired more than 900 Excalibur rounds in combat over the past decade. Raytheon is offering the Navy the N5 variant of its proven Excalibur. This version is designed to employ a dual-mode GPS laser seeker, although other possibilities such as millimeter wave seekers are being considered. The Excalibur N5 will offer a variety of fusing options tailored to the character of the target. Advances in miniature guidance systems, fuses and propellants now hold the prospect for even greater improvements to the performance of artillery gun projectiles while simultaneously reducing the price per round. Guidance technologies have advanced to the point that it will be possible to employ 155mm 5-inch guns against moving surface targets and even some aerial threats. Because the diameters of the 15mm and Mk45 5-inch gun barrels are those tests, which may have involved underwater charges, of the sort that damaged USS Cole, did not result in America's sinking. She was scuttled in the wake of the process. The short answer is that no one knows how many modern torpedoes a U.S. carrier could take before sinking, but we can estimate with little doubt that even a single torpedo would cause extensive damage, and severely impede operations. In 1943, the Germans used a precision-guided bomb to destroy the Italian battleship Roma. Such bombs soon gave way to self-propelled cruise missiles, which could launch from aircraft, ships, submarines, or surface installations. During the Cold War, the Soviets developed a dizzying array of platforms for launching cruise missiles at carrier strike groups, ranging from small patrol boats to massive formations of strategic bombers. Today, China, Russia and several other countries field a wide variety of cruise missiles capable of striking U.S. carrier battle groups. These missiles vary widely in range, speed and means of approach, but the most advanced can fly at high, often supersonic, speeds while offering a very low radar profile. As with torpedoes, the available evidence on the effectiveness of cruise missiles against a modern supercarrier is virtually nil. Much smaller ships have survived such hits, as have civilian tankers similar in size to CVN-78. Nevertheless, Even a non-fatal cruise missile hit would probably result in severe damage to the flight deck, impeding or completely stopping flight operations. The most important development in carrier-killing technology over the last decade has been the anti-ship ballistic missile, ASBM. The Chinese F-21 has the potential to strike American carriers from heretofore unrealizable ranges, and threatens to penetrate existing defense systems. The missile can maneuver in its terminal phase, targeting a moving carrier on a high-velocity final approach. The kinetic energy alone of the weapon could inflict devastating damage on a flight deck, putting a carrier out of action if not sinking it entirely. The development of the F-21 has forced the U.S. Navy to significantly step up its ballistic missile defense efforts. However, the ability of a U.S. task force to manage a large barrage of ASBMs is in great question. More than anything else, the development of the ASBM has forced the U.S. Navy to reconsider the role of the carrier in high-intensity warfare. The new Ford-class, CVN-78, carriers cost somewhere around $13 billion, a price that does not include the air wing. With a contingent of F-35CS, F/A-18E/Fs and various support aircraft, the price of an individual carrier is simply staggering, and the numbers go higher when accounting for the escort group that a carrier requires. Although the per unit cost will go down as more ships are acquired, the Fords take so long to build that each new ship will need to incorporate a host of new technologies, just as with the Nimitz class. The tolerance for large defense expenditure in the United States has varied considerably over the past 3 decades. The Trump administration has combined a fondness for increased spending with the grand strategy of retrenchment, an odd pairing. If retrenchment takes hold, then generating enthusiasm for defense spending may become increasingly difficult. And at some point, the military utility of an aircraft carrier may become literally irrelevant, relative to the cost of building, maintaining and effectively deploying the ship and its air wing. Maybe China and Russia don't need to kill a carrier to drive the species to extinction. All of the factors above, the weapon systems that can kill carriers, and the costs associated with the ships themselves, come together to create caution about how to use the ships. In the event of a conflict, U.S.
not as rogue groups like ISIS or Al-Qaeda, but China and Russia. While the U.S. has fought counterinsurgencies against small terror groups and non-state actors non-stop since September 11, 2001, the resurgence of an aggressive Russia now at war in Ukraine and Syria, and the emergence of China now unilaterally attempting to dominate the South China Sea, has renewed the U.S. military's focus on winning massive wars. The U.S. Navy has announced similar plans to grow its fleet size by nearly a third and shift tactics to better challenge Russia and China. But now the Air Force plans to grow in all directions at once, with more space, cyber warfare, logistical support, drones, tankers, and combat aviation all at once. The Air Force announced a goal of 386 squadrons, up from 312. Depending on the airframe, a squadron can have 8 to 24 planes. For the bomber squadrons, which include nuclear-capable bombers like the B-52 and B-2, that number will grow only slightly and likely include the mysterious new B-21 Raider bomber, which no one has ever seen outside classified circles. In the fighter jet department, it's likely F-35s will comprise most of this growth. Aerial tankers and intelligence, surveillance and reconnaissance platforms, likely drones, will also see a big bump. The Air Force hopes to build the force up to 386 squadrons by 2030, but has not provided any information on how it plans to fund the venture. The U.S. Air Force has requested $156 billion for next fiscal year, already a 6% bump over the previous year. While Wilson promised to streamline acquisition, which famously can take years and cost billions, there's real doubts about how fast the organization can move. The U.S. Air Force started working on the F-22 in 1981. It first flew in 1997 and first went into combat in 2014. The F-35 started in 2001 and just last year experienced its first combat in Israel's service. Additionally, the move would require the Air Force to bring on about 40,000 new people at a time when the force has a near-crippling problem with retaining top talent. We are not naive about the budget realities, Wilson said at the Air Force's annual Air, Space, and Cyber Conference. At the same time, we think we owe our countrymen an honest answer on what is required to protect the vital, national interests of this country under the strategy we have been given, and so we believe this is, if not the perfect answer, it is an honest answer to that question: what is the Air Force we need? Currently, China's military is in the midst of building up a tremendous air force and navy while also threatening some of the U.S.'s core interests and most promising technologies. The biggest U.S. Air Force defense projects involve stealth aircraft, like the B-21 and F-35.
Bomber will be able to hold any target at risk, anywhere in the world, at any time. Bunch, and former Air Force Secretary Deborah James have at times made reference, in merely a general way, to plans to engineer a bomber able to elude detection from even the best, most cutting-edge enemy air defenses. Our 5th-generation global precision attack platform will give our country a networked sensor shooter capability enabling us to hold targets at risk anywhere in the world in a way that our adversaries have never seen, James said when revealing the image last year. However, while Air Force developers say the emerging B-21 will introduce new stealth technologies better suited to elude cutting-edge air defenses, Russian media reports have recently claimed that stealth technology is useless against their air defenses. Russian-built S-300 and S-400 air defenses are believed to be among the best in the world. In addition, the national interest has reported that Russia is now working on an S-500 system able to destroy even stealthy targets at distances up to 125 miles. Nevertheless, James and other service developers have added that the new bomber will be able to play against the real threats. Although official details about the B-21 are, quite naturally, not available, some observers have pointed out that the early graphic rendering of the plane does not show exhaust pipes at all. This could mean that the Air Force has found advanced air suppressors or new methods or releasing fumes or reducing the heat signature of the new stealth plane. The Air Force has awarded a production contract to Northrop Grumman to engineer its new bomber. The next-generation stealth aircraft is intended to introduce new stealth technology and fly alongside, and ultimately replace, the service's existing B-2 bomber. Beyond these kinds of general points, however, much like the Air Force, Northrop developers have said virtually nothing about the new platform's development. With LRS-B, B-21, I can take off from the continental United States and fly for a very long way. I don't have to worry about getting permission to land at another base and worry about having somebody try to target the aircraft. It will provide a long-reach capability, Lieutenant Gen. Bunch, Air Force Military Deputy for Acquisition, told Scout Warrior in an interview last year. Prior to awarding the contract to Northrop, the Air Force worked closely with a number of defense companies as part of the classified research and technology phase. So far, the service has made a $1 billion technology investment in the bomber. We've set the requirements, and we've locked them down. We set those requirements, for the LRS-B, so that we could meet them to execute the mission with mature technologies, Bunch said. The service plans to field the new bomber by the mid-2020s. The Air Force plans to acquire as many as 80 to 100 new bombers for a price of roughly $550 million per plane in 2010 dollars, Air Force leaders have said. For instance, lower-frequency surveillance radar allows enemy air defenses to know that an aircraft is in the vicinity, and higher-frequency engagement radar allows integrated air defenses to target a fast-moving aircraft. The concept with the new bomber is to engineer a next-generation stealth configuration able to evade both surveillance and engagement radar technologies. The idea is to design a bomber able to fly, operate and strike anywhere in the world without an enemy even knowing an aircraft is there. This was the intention of the original B-2 bomber, which functioned in that capacity for many years, until technological advances in air defense made it harder for it to avoid detection completely. The new aircraft is being engineered to evade increasingly sophisticated air defenses, which now use faster processors, digital networking and sensors to track even stealthy aircraft on a wider range of frequencies at longer ranges. These frequencies include UHF, VHF and X-band, among others. Stealth technology works by engineering an aircraft with external contours and heat signatures designed to elude detection from enemy radar systems. The absence of defined edges, noticeable heat emissions, weapons hanging on pylons or other easily detectable aircraft features, radar pings have trouble receiving a return electromagnetic signal allowing them to identify an approaching bomber. Since the speed of light, electricity, is known, and the time of travel of electromagnetic signals can be determined as well, computer algorithms are then able to determine the precise distance of an enemy object. However, when it comes to stealth aircraft, the return signal may be either non-existent or of an entirely different character than that of an actual aircraft. At the same time, advanced in-air defense technologies are also leading developers to look at stealth configurations as merely one arrow in the quiver of techniques which can be employed to elude enemy defenses, particularly in the case of future fighter aircraft. New stealthy aircraft will also likely use speed, long-range sensors and maneuverability as additional tactics intended to evade enemy air defenses, in addition to stealth, because stealth configurations alone will increasingly be more challenged as technology continues to advance. However, stealth technology is itself advancing, and it is being applied to the B-21, according to senior Air Force leaders who naturally did not wish to elaborate on the subject.
A Marine Corps official speaking on background has confirmed to Air Force magazine that one of its F-35B fighters traveling with the Navy amphibious assault ship USS Essex launched an airstrike in Afghanistan in the past 24 hours, marking the first known combat strike for any U.S. F-35 strike fighter. A press release later issued by the service clarified that the airstrike occurred on September 27 and was in support of Operation Freedom Sentinel. During this mission, the F-35B conducted an airstrike in support of ground clearance operations, and the strike was deemed successful by the ground force commander, the release said. CNN first broke the story, citing 3 defense officials as its source. The F-35B first entered the U.S. Central Command area of responsibility earlier this month. Israeli F-35s made their combat debut earlier this year. The opportunity for us to be the first Navy, Marine Corps team to employ the F-35B in support of maneuver forces on the ground demonstrates one aspect of the capabilities this platform brings to the region, our allies, and our partners, 13th Marine Expeditionary Unit Commanding Officer Colonel Chandler Nelms said in the release.
Inherent to those UHF-VHF band systems. That's similar in concept to how a submarine hides in the background noise of the ocean. But, like all stealth aircraft, it will not be invisible. Stealth is not a cloak of invisibility, after all. Stealth technology simply delays detection and tracking. While the Air Force's rendering of the B-21 gives us some clues as to the configuration of the new aircraft, most of its other parameters remain unknown. The B-21's size and payload will largely be determined by whatever propulsion system is readily available to power it. Given that the LRSB is slated to enter into service in the mid-2020s, the aircraft will necessarily have to use an existing engine design. Moreover, that engine must have a profile conducive to a stealth aircraft. That would almost certainly rule out a commercial airliner engine derivative with a large bypass. Such an engine would have an extremely large diameter even if it is highly efficient. A more likely choice is a derivative of an existing military engine that is already in production. Possible choices could include unaugmented derivatives of the F-15 and F-16's Pratt & Whitney F-100 or General Electric F-110. The F-110, though an aged design, would give the LRSB commonality with the Rockwell International B-1 Lancer and Northrop B-2 Spirit, both of which use engines from the same lineage. The B-1's F-101 was derived into the F-110, which in turn was derived into the B-2's F-118 motors. An F-110 derivative does have its advantages, but the most likely candidate to power the LRSB is an unaugmented version of the Pratt & Whitney F-135, which in its current state offers roughly 28,000 pounds of dry thrust. With some tweaks, such as an increased bypass ratio. A version of the F-135 could probably produce more than 30,000 pounds of thrust while potentially increasing fuel efficiency. With two such engines, an LRSB would have less than the roughly 70,000 pounds of thrust available to the B-2, but there are indications that the B-21 is smaller than the Spirit. While the LRSB might be provisioned to accommodate whatever engine ultimately comes to fruition from the Air Force's Adaptive Cycle Engine program, variously called ADVENT, APT and EP, if the service is serious about an initial operational capability date around 2025, the new bomber will necessarily use an existing propulsion plant. It takes a long time and large sums of money to develop a new turbine engine. It's also not an endeavor without risk. Look no further than China's frustrated efforts to develop an indigenous jet engine. If one accepts the premise that the B-21 will be powered by twin unaugmented F-135 engines, one can then assume that the new bomber will be larger than a Boeing F-15E Strike Eagle or General Dynamics F-111 but smaller than the B-1 or B-2. Given the types of threats from low-frequency radars that are projected to be out there in the future and the limitations of current low observables materials, B-21's subsonic flying wing design will be large enough to counter low-frequency radars. A tactical fighter-sized stealth aircraft must be optimized to defeat higher frequency bands such the C, X and Q bands as a simple matter of physics, but a strategic bomber like the B-2 or LRSB can be larger to counter lower frequency radars. There is a step change in a stealth aircraft's signature once the frequency wavelength exceeds a certain threshold and causes a resonant effect. Typically, that resonance occurs when a feature on an aircraft, such as a tail fin, is less than 8 times the size of a particular frequency wavelength. That means a bomber like the B-21 has to have allowances for 2 feet or more of radar-absorbent material coatings on every surface, or the designers are forced to make trades as to which frequency bands they optimize the aircraft to operate in. As such, to defeat low-frequency radars operating in the L, UHF and potentially the VHF bands, this is easier said than done, and could in fact be impossible. A flying wing design is in effect mandatory. There are also
capabilities and design tools had made hypersonic development possible. Then, assuming O'Banion chose his verb tense purposely, came the surprise. Without the digital transformation, the aircraft you see there could not have been made, O'Banion said, standing by an artist's rendering of the hypersonic aircraft. In fact, 5 years ago, it could not have been made. Hypersonic applies to speeds above Mach 5, or 5 times the speed of sound. The SR-71 cruised at Mach 3.2, more than 2,000 miles per hour, around 85,000 feet. Computer processing power and new tools allow for three-dimensional design of a scramjet engine, O'Banion said at the American Institute of Aeronautics and Astronautics annual Sci-Tech Forum near Orlando, and scramjet refers to engine combustion occurring at supersonic speeds, which adds to the engineering complexity. Adding a little Hollywood to an engineering presentation, O'Banion likened the digital advances in 3D design to the build process Tony Stark employs in the film Iron Man. "We couldn't have made the engine itself, it would have melted down into slag if we had tried to produce it 5 years ago," O'Banion said. "But now we can digitally print that engine with an incredibly sophisticated cooling system integral into the material of the engine itself and have that engine survive for multiple firings for routine operation. The aircraft is also agile at hypersonic speeds, with reliable engine starts," he said. "A half-decade before," he added, "developers could not have even built it even if we conceived of it." Of course, none of the Skunk Works executives talk confirmed that Lockheed Martin is preparing to turn over to the Pentagon a top-secret hypersonic aircraft, nor does it reveal how far the project may have progressed. It's also unclear if such an aircraft would carry pilots or operate as a drone. Lockheed declined to address O'Banion's comments. The defense contractor continues to advance and test technologies, which will benefit hypersonic flight, spokeswoman Melissa Dalton said in an email. A reusable hypersonic system is a far-term solution that will be made possible by the pathfinding work we are doing today. An Air Force spokesman, meanwhile, said only that the military has no information on the project at this time. Talk about Lockheed's hypersonic program isn't new. In fact, executives discussed the program's status to such an extent last June that defense reporter Tyler Rogaway called it highly peculiar.